The distinction between discrete and continuous variables is particularly important when it comes to probabilities. Let's look at a practical understanding of the difference. Discrete tends to be countable, while continuous has infinitely many values even within a small range. A forest, for example, the number of trees is discrete. It could have 158 or 159 trees, but not 158.337 trees. It's discrete. But the acreage has infinitely many values, even in a small forest having somewhere between 2 and 3 acres of area. It could actually be 2.435 acres, for example. Continuous values are possible. Number of lakes in a county, that's discrete, but the volume of a lake in gallons is continuous. It could be 5.0803 million gallons. Think of me driving home to be with my wife after a long day during which I drank too much coffee. Yep, I love my wife, and yep, I drank too much coffee. Just kidding, I'm really old and drive slow. I have to fast forward just to look fast. It's a metaphor for my life, actually. Anyway, the speeds I could travel are infinite. Now, on the freeway, people may yell at me for driving somewhere between 52 and 53 miles per hour with a tailwind, and as I speed up from 53 to 54 miles per hour, I theoretically would travel at infinitely many speeds in any one moment during my acceleration. At one point, I must have been traveling 53.7728 miles per hour. Thus, my actual speed is continuous, infinitely many possible values within an interval even from 53 to 54. Meanwhile, my speedometer is digital.
It only goes from 0 to, I believe the trees are passing by a little too quickly now.
For the sake of this example, suppose that the 6.8 on the speedometer is the speed. So, as I'm speeding up from, let's say, 53 through 54 miles an hour, it can only register speeds of 53.1, 53.2, up through 53.9. Therefore, the speed of my speedometer is a discrete variable, but the actual speed my car can travel is a continuous variable. Now, the normal distribution is going to be the cornerstone of statistics, so we'll understand later that a variable that's normally distributed is a continuous variable.